Some more kitchen table astronomy at Hampshire College astronomer Dr. Salman Hameed, Mr. Universe's kitchen table in Amherst. Last week, Mr. Universe, my dad texted me specifically to ask about my injured finger, but then also said, that astronomer, I love him. And I was like, wow, my dad doesn't even compliment me on anything, so he loves our chats.
Well, thank you very much. And that does happen, by the way. Your parents actually always see, oh, that guy is good.
What about me, Dad? What about me? Today we're talking about juice.
Yes.
So like Tang. Tang is the juice of astronomy, of course, because that's what astronauts drink.
That's exactly right. And so the legacy, as we say, continues.
Uh-huh.
And this time it's to Jupiter.
Uh-huh.
So this is a...
juice is not, we're not really talking about Tang.
Right, just to be clear about it. No, this is a really cool mission that got launched last Friday. And so this is a European Space Agency mission. So in case you haven't heard of it, because NASA has a pretty good publicity thing. European Space Agency doesn't, but this is a very cool mission. It's called JUICE because, again, they came up with a good acronym. It's Jupiter Icy Moon Explorer. Uh-huh. And so it is going...
Wait a minute, moon is an
moons,
M.
Moons. And so multiple moons. It's not just going to one moon. And yes, no, it's not.
Wouldn't it be Jime? Jupiter Icy Moon Explorer says Jime to me. Isn't it another language?
No, well, no, but I think that's the easiest way they could do it. Okay. And it's the J and then I guess
the JU of Jupiter and then the ice. I see.
Sheesh, we are going into the semantics part of it.
Is Lizzo on this mission? She was on The Mandalorian.
That's true. Yeah, no, she's not. But so this mission, it's a $1.6 billion, so it's not a small mission. And this is going to explore, as it says, with JUICE, the moons of Jupiter. So its primary target is not the planet itself, but some of its moons.
Mm-hmm. And there's one moon in particular that people seem to be very interested in. Ganymede, right?
Mostly when people think about Jupiter's moons, people think about Europa.
Yeah.
And there is a NASA mission, Europa Clipper mission that's going to be launched next year. But this particular mission by European Space Agency is in fact, in particular, going to Ganymede, but it's also going to have 2 flybys of Europa and another moon, Callisto.
Well, so, I mean, if you're the European Space Agency, you've got to visit Europa, or else it's like not being in your hometown and not visiting your parents.
That's true. But
hi, Dad. Do you love the astronomer still?
but so let me clarify what's cool about this. So I actually watched the live launch of this JUICE mission from the French Guyana, and it was the European Space Agency launches from there, or an Ariane 5 rocket, and it's like, you're sitting there, you're watching it launch. I would love to go see it live also. Yeah. But just think about it. It came up with sort of like, got all these instruments, the spacecraft. It has, I think, 10 instruments on it. And they put it on top of the rocket. This is, by the way, a similar rocket that took James Webb Space Telescope up as well from the same location. And then you launch it. And you see it, wow, very precise. They said it was delayed a little bit, but then it was like, it's going to launch in Eastern time, 8:14 a.m. Mm-hmm. And sure enough, at 8:14 a.m., it launches. Okay, and it goes up, and they say after 24 minutes later, sort of like, its final stage, it's going to be, and it's going to get sort of like separated, and the spacecraft will be on its own. And you go like, wow. And then, but when does it get to Jupiter? Well, July of 2031.
What?
That's right.
So why did it have to leave at exactly 8:14 on April, whatever it was on Friday?
Well, that's what's the crazy part about these things, is because it has to be very precise. There are very specific launch windows, but it takes a long time. And this has a crazy trajectory because it's going to use what is called the gravitational assist from Earth itself, but also from Venus, and then back to Earth, and then it's going to slingshot all of its way to Jupiter.
And that's how it works, right? It goes around the orbit, and it's like a slingshot. Like, I don't know if it's centrifugal force when it's in outer space, but it like wraps around the orbit of the moon and then shoots out faster than it would have if it just straight launched, right?
Right. I mean, it's the energy exchange. It gives some energy to Earth too, but Earth, doesn't happen much. But the energy it gives to the spacecraft, actually, it propels it outwards further. So think about it. People have to plan for it. And then, that, okay, in 2031, it's going to get there. And first, it's going to take about 35 flybys, 2 of Europa. There will be 21 flybys of Jupiter's moon Callisto. Now, Europa, we know it's interesting because we know there is a liquid water ocean underneath. That water is salty as well. And many spacecraft, Galileo spacecraft back in the 90s actually showed, first it was observed by Voyager close by, but then Galileo spacecraft really showed that there are like icebergs over there, and there is this ice sheet. We don't know exactly how thick it is, maybe 10 miles or so, but underneath there is a liquid water ocean because there is volcanic activity right at the base of it, and that's because of Jupiter's tug and forth, sort of like, it just makes the core warm, and that causes sort of like, heat coming out, and that melts the ice.
Like the plate tectonics of Jupiter's moon.
It's a different mechanism. It's more like slushing, sort of like, because of Jupiter, it pulls on the near side of Europa more than the far side.
Ah.
And so that actually slushes it. And as it goes through, different parts of the moon are constantly being tugged. And so it's like a squishy ball if you keep on doing it like this. So this is Jupiter's relaxation method.
Oh, good. Yeah. When you do it enough at home, you'll have a volcano in your hand.
And if you're too close, then it's all volcanoes, and that is with Jupiter's moon Io. So that is actually, we know there is active volcanism over there. But if you go a little bit further up, like Europa, you have a sheet of ice that prevents the water from evaporating in some sense, and then underneath that sheet, you have liquid water, and underneath you have volcanoes. And in some sense, the reason why this is exciting is because these are the same conditions or similar conditions of underwater volcanoes here on Earth. And many people think actually life may have even started around these underwater volcanoes. And so you have organic matter, which is abundant in the universe. You have liquid water, and you have energy source, which is heat. And so all the conditions that should lead, or at least on Earth, it led to life, origins of life. So that's why there is a lot of excitement about at least Europa. And as I mentioned, there are missions going over there. There's a NASA mission next year as well. But there is another moon of Jupiter. There are 4 big moons. Io, I've already mentioned, that's closest. Then you have Europa, and then you have Ganymede and Callisto. These are the 4 Galilean moons. Galileo observed them back in the 17th century.
Just an old-fashioned telescope.
Really old-fashioned. I mean, some of the earliest telescopes. Jupiter has a lot more moons, and in fact, recently they found 12 moons. So I think, I don't know, right now, I think that grand total is like around 85 or something.
We got ripped off. We only have 1 moon.
But these big moons, you can see them through a small telescope at night. Jupiter is visible. You can see through these 4 big moons, and you can actually see them over the period of night or over a couple of days. They're different locations because they move, and that's what Galileo also noted. But Ganymede, that's the target, because astronomers think that there is a liquid water ocean underneath Ganymede as well. And Ganymede is big. It's in fact bigger than Mercury.
Uh-huh.
And so it's a big moon. It's a little bit bigger than Mercury. It's the only moon that we think of has its own magnetic field, because it has a sort of like, molten iron core. It produces its magnetic field. And so JUICE mission, one of the things that it's going to do is to measure its magnetic field, look at its magnetic field, analyze it. Jupiter has magnetic field as well, so it's going to sort of like disentangle between the two. But ultimately, what it's going to do is, after multiple flybys of the 3 moons, Europa, it's going to make about 21 flybys of Callisto. Look, Callisto, if there are Callisto fans out there, it's not that exciting. I mean, we don't think there is liquid water ocean. There's still debate about it. So it may actually find evidence for liquid water ocean, but they think that more likely it's sort of like, more dormant in that context. Mm-hmm. It's a little bit too far away from Jupiter to have ocean underneath. But it's still going to have 21 flybys, and this is the first time that's going to have that kind of observations from there. But then, in I think a few years after doing all these flybys, it's going to set into orbit in December of 2034. So 11 years from now, and we can tell you, okay, December of 2034, it's going to get into orbit around Ganymede. And it's going to be around roughly around 3,000 miles above, and then it's going to get tighter and tighter and tighter, and eventually it's going to go around to 300 miles, and it's going to make observations of Jupiter's moon, Ganymede. And what it is looking at, we think that the ice sheet of Ganymede is thicker than that of Europa. So it can actually figure out sort of like, it has a radar that can penetrate through ice, but only to 10 miles. So it cannot go all the way, but even that, astronomers expect that there are variations in the various ice sheets that are around Ganymede, so it may be able to map out the interior. And I think that there may be like different layers of oceans, and there are some sort of like, no, there are ridges, there are grooves up on Ganymede's surface. It's a really cool surface. Check it out if you get a chance, sort of like, the pictures that we have so far. And they think that there might also be cryovolcanism, basically water coming out from underneath. There may be some spots. Europa certainly has that. And when it's going to be going over there, flying by Europa, if there are plumes coming out, it actually will probably pass through those plumes. But on Ganymede as well, it's going to try to map out, are there spaces, are there places where there are pockets of liquid water? And again, all of that we are looking at because the potential for life.
There's no place on Earth where these conditions exist. Even though at times in even Earth's history, it seemed like life could not thrive in these deep underwater volcanic vents, life does exist. So the fact that these factors are all on these moons surrounding Jupiter is high potential.
Yeah, and in fact, I would say that, especially for Europa, that I think I would be far more surprised if there is no life than there is. Meaning to say the likelihood, and we're not talking about sort of like, fish or sort of like, complex.
But wouldn't that be cool if JUICE gets this radar image at Ganymede and they see like the Loch Ganymede monster under the ice, huh? That'd be amazing.
Yeah, but that would be well. There have been spacecraft before, like Galileo, that have actually gone around, although not as close to it. But yeah, that would be cool. Or I guess polar bears won't be on that surface. That would be pretty hard.
Polar bears are scary here, so.
But yeah, we don't know what's underneath. I mean, in some sense, you have a system. We don't know if it's an ecosystem that has biology or not, that has thrived, right? So especially, again, I go back to Europa, where the likelihood is more for potential of life. Well, we don't know what's underneath the ice sheet. And so you can have species that are there. And again, on Earth, for several billion years of our planet's history, we only have had microbial life. That was on top of the food chain. So it's pretty likely that that you have an ocean that has a lot of microbes in there, because all the conditions are there, but may not have developed into complex life forms. Or maybe things like tiny little fish or the ocean plants. It's a possibility. We really don't know, and that's where NASA's Europa Clipper mission comes in. That's going to launch next year, but it's going to get to Jupiter actually a little bit before before JUICE. They have a stronger rocket that's sending it over there. It's going to get there in 2030, and that is going to again look around Europa, and it's really going to figure out potential landing sites for future missions. JUICE is also going to help with that, and it's going to so they're going to try to figure out that.
Wasn't there science fiction warning us not to land on Europa?
Arthur C. Clarke warned us in, I think, 2010, in which he said, or maybe it was 2001, I forgot. No, it was 2010, in which it said that all solar system bodies are yours except Europa. Attempt no landing there.
And of course we have to go do it.
And you know who's not doing that? The Europeans. They're going like, we'll make an attempt. Well, eventually, Ganymede, Europa. No, they took Arthur C. Clarke seriously. We have not. But in all of that, I should end with a bit of a caution and a bit of something that actually worries me when I read about that. and the question is, how do you end a mission? And so the Galileo spacecraft that orbited over there was eventually crashed into Jupiter because we did not want to contaminate places like Europa, but certainly, but also like Io, because we know life can exist actually in near volcanoes as well. Certainly Ganymede as well, and the mission, the Clipper mission, is also intended to crash into Jupiter eventually at the end of it, because we don't just, after the fuel is over, we don't just want to leave it sort of like in an uncontrolled orbits, because it can end up in there. And we try very hard, and astronomers or scientists try very hard to decontaminate them. But these critters, they can be sort of like really resilient, because we know some of them can survive interstellar space as well. So we just don't want to take that risk to
So if one microbe exists on JUICE or on the Clipper mission and goes onto Europa or onto Ganymede, it could, in a billion years, have seeded life from Earth, essentially, as opposed to watching life organically grow up on its own from somewhere else.
Or taking over the life form, like, that is over there. I mean, you are really introducing something. So there are these effects we often think of in terms of reverse planetary defense, where we don't want Earth to be contaminated by. There is a lot of issues regarding bringing samples back from Mars, and there is a lot of debate about how to do it safely. But same thing goes when spacecrafts do landings, say for example on Mars or these type of missions. There's a lot of concern about introducing Earth microorganisms over there. But the end of JUICE mission right now is expected to actually crash into Ganymede. And I was actually surprised when I read that, and they said that unless they do find some stronger hints that there might be life, then they are going to change the trajectory and try to actually. So they will have to save a lot of fuel to actually exit the orbit around Ganymede to go and crash into Jupiter. But right now, as far as I can tell, and that's what I read, and I was very surprised. Right now, the sort of plan is that eventually it's going to crash into Ganymede, they think, because the ice sheet is so thick that, sure enough, a small spacecraft, even though it weighs about, I think around 10 tons, 6 tons, that, it's going to go in, add a little crater to it. That's okay, no big deal. But that's my only concern. But other than that, really cool mission. So keep following it, and watch for our follow-up to this conversation in 2031.
I hope I still have a show then.